A function in C++ is a block of code that performs a specific task when it is called. Functions help to modularize the code, making it more organized, reusable, and easier to understand. In this tutorial, we will go through the basics of functions. A function has the following syntax: return type, the data type of the value that the function returns. If the function doesn't return any value, we use the keyword void, V-O-I-D. Function underscore name, the name of the function, so this is used to call the function. Parameters, it is the list of input values or arguments the function takes, separated by commas. If there are no parameters, you can leave this empty. Before using a function, you need to declare and define it. The declaration includes the function signature. For example, its return type, the name of the function, and the parameters. The definition contains the actual code that the function executes. This program demonstrates a simple program that uses a function to add two numbers and print the result. So let me explain each part of the code. Integer add, integer x, integer y, and a semicolon. This line is a function declaration, or called a function prototype. It tells the compiler that there's a function called add that takes two integer arguments, x and y, and returns an integer value. The function declaration is necessary because C++ requires functions to be declared before they are used. Then integer main, this is the main function of the program. Every C++ program must have a main function, which is the entry point of the program. The main function contains the code that will be executed when the program is run. Inside the main function, the program initializes two integer variables, a and b, with the value 5 and 10, respectively. Integer sum equal add, then in the parentheses we have a, b. This line calls the add function with the values of a and b as arguments. The control flow transfers to the add function. Inside the add function, the program calculates the sum of the two input arguments, x and y, which correspond to a and b from the main function. By evaluating the expression x plus y, the result of this calculation is returned to the calling function in main. The control flows returns to main function, and the result of the add function is stored in the sum variable. The program then uses cout to display the value, the text sum, and a colon, and the value of the sum variable and the new line character. Finally, the program reaches the return 0 statement, which indicates the program has finished executing successfully. The control flow exits the main function and the program terminates. So in this example, we pay attention to the function prototype. It is placed before the main function. It specifies the function header and a semicolon. The parameter names are optional, so you can just have the parameter type. In this case, you can just have integer. The function call, second, we need to pay attention to the function call. It is an instruction to execute a specific function that has been previously defined in the program. When a function is called, the control flow moves to the function definition where the function's body is executed. Once the function has completed its task, the control flow returns to the point where the function was called, and the program continues executing the next instruction. The function definition is implemented after the main function. You can also place this function definition before the main. In this case, the function prototype is not needed if you directly place the function definition before the main function, because the compiler knows how the function is implemented. So there is no semicolon after the function header in the function definition. There are curly braces for the body of the function. The functions can either return a value or have no return value. The difference lies the function's return type and how it is used in the program. In this example, add function return a result, which is integer type. So we need to put integer before the function names, and in the function call, we assign the result to a variable. A function with no return value has the void return type. It performs an operation but doesn't return any value to the caller. In this example, the print sum function has a void return type, meaning it doesn't return any value. Instead, it directly prints the sum of x and y inside the function. We put the keyword void before the function name. In the function call, it is standalone with no assignment operator. There are two ways to pass parameters to a function in C++. The first type is pass by value. So this method creates a copy of the original variable and passes to the function. Any changes made to the variable inside the function don't affect the original variable. Second type is pass by reference. So this method passes the reference or memory address of the original variable to the function. Any changes made to the variable inside the function directly affect the original variable. This program demonstrates the difference between passing a variable to a function by value and by reference. First, we have a void pass by value integer x. So this is a function declaration for pass by value, a function that takes an integer argument and has no return value. We know it is passed by value because for the parameter integer x, we don't see an AND symbol. The second function, void pass by reference integer AND symbol and x. So this is a function declaration for pass by reference, a function that takes an integer reference argument and has no return value. We know this is pass by reference because we see an AND symbol after the data type of parameter integer and x. So this AND symbol specifies this x is passed by reference. And then we see an integer main. This is the main function. Inside the main, we declare an integer variable a and assign the value 5 to it. Then we call pass underscore by underscore value, and we pass a argument. So we call the pass by value function with a as an argument. This function receives a copy of a. So any changes made to the parameter x inside the function won't affect the original variable a. The control flow goes to pass by value function definition. Inside, it takes a copy of integer and adds 5 to it. The original variable passed to the function remains unchanged. Then we see out after pass by value the a value ENDL. So it prints the value of a after the pass by value function call. This value of a remains unchanged as the function only modified its local copy of the value. Then we have a function called pass underscore by underscore reference a. So this call the pass by reference function with a as an argument. This function receives a reference to a. So any changes made to the parameter x inside the function will affect the original variable a. The control flow goes to pass by reference function definition. It takes a reference to an integer and adds 5 to it. The original variable passed to the function is modified as well because we pass the memory address of the parameter. After the function call, we see out after pass by reference the value in the a and ENDL. It prints the value of a after the pass by reference function call. The value of a has changed because the function directly modified the original variable. When you run this program, the output will be like this. As you can see, after the pass by value function call, the value of a remains 5, while after the pass by reference function call, the value of a is changed to 10. Therefore, if we see an AND symbol before the parameter, it is passed by reference. Otherwise, it is passed by a copy of a value. Scope refers to the region of a program where a specific identifier, such as variable, function, or class, is accessible and has a valid lifetime. There are different types of scope in C++. First one is a global scope. Identifiers declared outside any function or class have global scope. They are accessible from any part of the code after their declaration. Global variables have a lifetime that lasts for the entire duration of the program. In this code, a global variable, global var, is declared outside the main function, which means it has a global scope. It can be accessed and modified from any part of the code after its declaration. The main function then assigns the value 10 to global var and prints its value to the console using cout. Local scope. The identifiers declared within a function or a block of code have local scope. They are accessible only within that function or block and have lifetime that lasts until the end of the function or block. In this code, a local variable, local var, is declared inside the main function function. This means that it has a local scope. It can only be accessed and modified within the function where it is declared. The main function assigns the value 5 to local var and prints its value to the console using cout. Then the main function calls my function, which prints the value of local var. However, local var cannot be accessed outside of my function, and any attempt to do so will result in a compilation error. If the function has parameters, the scope of formal parameters is the same as the scope of local variables defined at the beginning of the function. Static local variables are variables that are declared within a function using the static keyword. Unlike regular local variables, static local variables retain their values between function calls. They are initialized only once, when the function is called for the first time, and their lifetime extends throughout the program's execution. Here is an example to illustrate the use of static local variables. In this example, the count variable is declared as a static local variable. Within the counter function, each time the counter function is called, the value of count is incremented and printed. Since count is a static local variable, it retains its value between function calls. So the output shows the value of count increasing with each function call. In C++, you can provide default arguments for a function's parameters. If an argument is not provided during a function call, the default value is used instead. This can be useful when you want to create a function with optional parameters. Here's an example to illustrate the concept of default arguments. In this example, the add function has three parameters, a, b, and c. Parameters b and c have default values of 0. When calling the add function with 1, 2, or 3 arguments, the default values are used if the corresponding arguments are not provided. Function overloading in C++ allows you to define multiple functions with the same name but different parameter list. The compiler differentiates between these overloaded functions based on the number and the types of the arguments passed to them. This can be useful when you want to create multiple variations of a function to handle different data types or a different number of arguments. In this example, we have two overloaded add functions. One takes two integer parameters and returns integer value, and the other takes two double parameters and returns double value. When we call the add function with integer arguments, the integer version is called. When we call it with double arguments, the double version is called. Function overloading in C++ is a feature that allows you to create multiple functions with the same name but with different parameter lists. This provides the flexibility to perform various operations or tasks using a single function name. To overload a function, you simply define multiple versions of the same function name, each with a unique set of parameters. The parameters can differ in terms of their type, order, or number. The compiler automatically chooses the appropriate function to call based on the arguments passed during the function call. It is important to note that the function overloading only works when the parameter lists are different. You cannot overload a function based on its return type alone. The compiler would not be able to determine which function to call solely based on the return type. Let's write a program that calculates the area of different shapes using overloaded functions. The program should ask the user to input the type of shape for which the area needs to be calculated. The possible shapes are circle, rectangle, or triangle. If the user selects a circle, the program should ask the radius, and for a rectangle, the program should ask for length and width. In the case of a triangle, the program should ask for the base and the height. The program should use three overloaded functions named calculate area to compute the area of the chosen shape. Each function should accept arguments relevant to the shape and return the calculate area. For a circle, the function should accept one argument, which is radius. For a rectangle, the function should accept two arguments, length and width. For a triangle, the function should accept two arguments, base and height. Finally, the program should display the calculate area for the selected shape. We also have an input validation. Don't accept negative numbers for any input data. Here is how we consider to write the program. We first include necessary headers in the declared namespace. Then we define the overloaded functions. And this time we just have the implementation definition there to replace the prototype, because if we put the function definition before the main function, we don't need the function prototype. So we define the overloaded functions for calculating the area of different shapes. Then we define the main function. We define the main function where the user will be prompted to choose the shape and input its dimensions. The main function will also call the appropriate overloaded function based on the user's choice. For the menu, we use switch statement. Inside the main function, we implement the switch statement that handles the user choice of shape and calculates the area using the appropriate overloaded function. Case 1 is for circle. We prompt the user to input the radius, validate input, and call the calculated area double function, and display the result. Case 2, rectangle. We prompt user to input the length and width, validate the input, call the calculate area double because this time we have two parameters. One is for the length and one is for the width. And we display the result. Case 3, for triangle, prompt the user to input the base and the height and validate the input, call the calculate area double and bool function, and it displays the result. Then default case, we display an error message for an invalid choice and terminate the program. Then we compile and run the program. Let's do the program. First, we start by including the IO stream header, which provides functions for standard input and output. The std namespace is used to avoid having to type std : before cout and cin. The function prototypes for the three overloaded calculate area functions are declared, indicating that the program will use 3 functions to calculate the area of different shapes. To differentiate the calculate area function for rectangle and the triangle, we add additional parameter in triangle. The third parameter is Boolean parameter. Otherwise, the compiler will think those 2 functions are duplicate function, which is error. So we have to use different parameter list to differentiate the 2 functions. The main function is the entry point of the program. It starts by prompting the user to choose a shape, circle, rectangle, or triangle, by entering a number between 1 and 3. The program uses a switch statement to process the user choice. Depending on the shape chosen, the program prompts the user for the required input data: radius, length and width, or base and height. The switch statement is designed to handle the user's choice of shape, circle, rectangle, or triangle, for which the area will be calculated. Each case block represents the corresponding shape and calculates the area using the appropriate overloaded function, calculate area function, based on the input dimensions. Case 1 is for circle. So if the user chooses 1 or circle, the program prompts the user to enter the radius of the circle. It then checks the radius is negative, and if so, displays an error message and terminates the program. If the input is valid, it calls the calculate area double function with the radius as an argument, which calculates the area of circle and then displays the result. Case 2 for rectangle. If the user chooses 2, which means rectangle, the program prompts the user to enter the length and width of the rectangle. It checks if either the length or width is negative, and if so, displays an error message and terminates the program. If the input is valid, it calls the calculate area double function with the length and width as arguments, which calculates the area of the rectangle, and then it displays the result. Case 3 is for triangle. If the user chooses 3, the program prompts the user to enter the base and the height of the triangle. It checks if either the base or height is negative, and if so, displays an error message and terminates the program. If the input is valid, it calls the calculate area double bool function with the base, height, and the true flag as arguments, which calculates the area of the triangle, and then it displays the result. If the user enters an invalid choice, not 1, 2, or 3, the default case block executes, displaying an error message indicating an invalid choice. The program then terminates with a return value of 1. So in each case block, after performing the calculations and displaying the result, a break statement is used to exit the switch statement, preventing the execution of the subsequent case block. Now we finish the main function. The overloaded calculate area functions are defined outside the main function. It's after the main function. Each function takes a different set of parameters depending on the shape it calculates and the area for. For calculate area, the circle function, it takes a single parameter, the radius, and returns the area of circle. For rectangle, it takes two parameters, length and width, and returns the area of rectangle. For triangle, it takes three parameters, base, height, and the Boolean flag indicating it's a triangle, and returns the area of the triangle. By using function overloading, the program can calculate the area for different shapes with a single function name, making the code more organized and easier to understand. Hello, let's take a look at the exercise after Chapter 6, the Programming Challenge Markup. Write a program that asks a user to enter an item's wholesale cost and its markup percentage. It should then display the item's retail sale. For example, if an item's wholesale count is $5 and its markup percentage is 100%, then the item's retail price is $10. If an item's wholesale cost is $5 and its markup percentage is 50%, then the retail price is $7.50. The program should have a function named calculate retail that receives the wholesale cost and the markup percentage as arguments and return the retail price of the item. So we have two inputs from the user. One is the wholesale price and one is the markup percentage. And we call the function. The function has two arguments. One is for the wholesale price and the second one is the markup percentage. The question also said input validation. Don't accept negative values for either the wholesale cost of the item or the markup percentage. We will have a loop, while loop, to verify the input are not negative. They must be positive. So the subtask will be, first we declare variables. Second, we get input, wholesale, and we validate it. We use while loop to validate it. We get input markup and validate it. We write the function calculate retail, and we will call this function, right? So we have we will talk this later. How do we use a function? Then we display the result. Let's start from an empty project. The first thing is we write some comments. Chapter 6, markup project. First thing we need to hashtag include IOStream. Then because the dollar, we will display the dollar. So the dollar usually has a point, right? You can see that because we have a pennies, that we have to show the point for the decimal point, and then we have a precision too. So we'll have some formatting, and we will need to include IO manip. Then using namespace std semicolon integer main, then curly braces, and inside we will write code inside this block of curly braces. So the first thing is we declare the variable. So double wholesale, that holds the wholesale cost. So we cannot use integer, right? If the integer, we will truncate the penny part. We need the dollar parts and both the dollar parts and the penny parts. The second variable is markup. So the same thing, the percentage. Percentage we also use double markup. semicolon. And we assume we ask the user to enter, for example, 100%. So the user just enter 100. Another example is the percentage is 99.5%. So the user just enter 99.5. So it should be declared as a double. Then we are going to get the input. The first thing we output some message. Please enter the wholesale cost. Then we say cin the wholesale semicolon. So now we are going to use while loop to validate while the condition wholesale is less than 0, right? In the curly braces. So we will output a message. We say cout. Please enter a positive value for the wholesale cost. Semicolon. Here we don't want to change the line, right? We don't want to have an ENDL because the user can input right after the same line, on the same line of this message. Then we cin wholesale again. So this while loop will continue run when the wholesale is less than 0. Once the user enters a wholesale equal or greater than 0, the while loop, the condition fails, so it will stop. We can do the same thing for markup, so we can just copy and paste this code, and then we change the variable name to markup. We also change in the message markup percentage, and then also change the markup variable name here. Be very careful. I also see we need to change the markup variable name in while loop condition. Okay. So seeing this wholesale, verify the wholesale less than 0. If it is less than 0, we'll do the while loop to continue seeing the wholesale. Same thing, we get input from markup and check if markup is less than 0 in the while loop. Then in the while loop, we will continue to get input of markup. So next thing is we can assume we have a function. We know the function will return a value. This value you can either put in the cout statement because it's a value, or you can assign to a variable. So let's see, we can just cout the result. Cout. First is the message. The items retail price is in dollar. So that's the string. That's for the message. And because we know it's a dollar part, then point, then penny part. So we set precision to, and we want to show the decimal point, fixed show point. Then we call this function. Let's say we name it as a calculate retail, right? This is the function name. And the two arguments is wholesale is the first argument. The second argument is markup. Because it's a calculate retail function return a value. Okay, so we can just put in the cout statement. Then we continue to have a period, then ENDL. And return 0. See, it shows, what is calculate retail? See the red line under it, so that's a warning. So let's define this function. The first thing is better to have a function definition before main. So it gives a heads up to the compiler what is this function. So let's paste here, and the function definition must be ended with semicolon, and this function returns double, so we put the double type in front of the function. And for the arguments, we first is a double because the wholesale is double, and second argument is double also for the markup. And here we pass by copy, right? Pass by value, not pass by address or pass by reference. So you can also skip the argument name. So this is the definition for the function. Return type, function name, and the argument type. And the argument must be in order, the same order as when you call it. Okay. So this is definition. Then we're going to implement this function. And the function should be outside the main function, right? So we go outside the block of the main. And for the implementation, you don't have the semicolon because we will have a curly braces block under it. So for the implementation, we need to specify the argument name. You can have the same name here, wholesale, in the markup. Because we pass by value. So if we change anything, we say wholesale. We just have an example. We increment wholesale. The wholesale in the main function will stay same because we just pass a value, pass a copy of them. So they don't change. The wholesale in the main function, they don't get changed. The retail price should be the wholesale plus the wholesale multiply markup multiply 0.01. Because the user enter markup like a big number, not a percentage. We need a decimal representation of the number. So we can just say return this value, which is a wholesale plus wholesale multiply markup multiply 0.01 and a semicolon. And let's compile this program. And run it. Let's say 50. It didn't show anything. Is this a infinite loop or something? Let's check. So we first just seeing the wholesale. While wholesale less than 0, we output the message, and then we seeing the wholesale again. So we seeing markup. Oh, okay. Before we seeing the markup, we should also output the message to ask a user to input the markup. So let's say cout, please enter the markup percentage. Then just a semicolon, because we want the markup number on the same line as this message. So let's run again. $50, $50. Okay. $10, $100, that's $20. Looks fine. Let's do another example. Let's write this as a procedure. So it's a void, return nothing. And let's also pass by reference, see what happened. So I comment all those. So let's have a different definition. We can say void calculate retail. Then we can pass by the first two from parameter, we still pass by value. So double. And the third one, we can pass by reference. So we have also double here. But after this double, we need to have a n%. So that shows this argument will pass by reference. Then inside the main function, okay, we can still use this statement, but we can modify it. So cout. Let's first declare a variable. This variable called the retail price. Equal 0. Okay. So we have a new variable, retail price equals 0. Then we call this function calculate retail, because it's void, so it's a standalone. It doesn't return the value to a variable. So calculate retail wholesale markup. Then we also pass the retail price. And the retail price is passed by reference. So we can update the value inside the function implementation. Then we are going to implement this. So we have a new function implementation. Here we say void calculate retail double wholesale double markup, then comma double and n% retail price, then curly braces. So the inside we can say retail price equal to this calculation, which is wholesale plus wholesale multiply markup multiply 0.01. So we have this calculation and we assign the result to retail. And the retail passed by reference. So when we call it in the main function, the retail price will get updated by the calculation inside the calculated retail subprocedure. We should call it subprocedure. So here, when we output cout the item price, $, set position, fixed show point, and here we just say change to retail price. Okay, let's build. Looks like no error, and run it. So 50, still the 75, which is correct. $10 for wholesale, and the markup is 100%. 20. Oh, it's a wholesale, it's not wild sale. So let's change wholesale. Okay. 50. Okay. So we see here two examples. First, we write as a function. Then we write as a procedure. And in the function, we just pass two arguments by value and they return the result. For the procedure, we say it's a void. It doesn't return anything, but we can pass argument as passed by reference or passed by address. So inside the procedure, we will update the value for the argument. And because it's passed by address, so actually the retail price in the main, the value will get updated also.